What is the greatest common factor of 18n to the third and 27n? So I would just start like this. Okay, and maybe you look at this and you kind of see it in your head, which is fine. But if we say, okay, this 18, n to the third is 3 times 3 times 2 times n times n times n, right? Those are the factors. Now, 27 is 3 times 3 times 3, and this is times n. So what I'm looking for is common factors here. So I see a 3 and I see a 3. I see another 3 and I see another 3. And I see an n and I see an n. And there's nothing more for me to circle here. There's a 3 here, but there's no more 3 here. There's a 2 and some n's here, but there's none of that over here. So my greatest common factor is 3 times n. That's 9n. What's the greatest common factor of 35, 70, and 45? So right away, I notice 5 and 7. And so I'm thinking to myself, well, these are both prime. So, right, if I'm looking here, right, there's another 5 and 7 here. Okay, so I might be thinking, ooh, 5 and 7. But then I come here and I'm like, oh, this is 5 and 9. Okay, so yes, I can keep factoring this 9. It turns out I don't really need to, right? I notice the 5, I notice the 5, I notice the 5, and I think there's nothing else in common, right? 7 is prime, so there's nothing else that's going to be in common from there. And so the greatest common factor here is 5. Here, I'm looking, okay, let's look at the numbers first. So I'm looking at 8, 12, and 20. And I think to myself, 8 is 4 times 2. And I think, let me factor that 4, right? This is 2 times 2 times 2. 12 is 2 times 6, and 6 is 2 times 3. 20 is 4 times 5, which is 2 times 2 times 5, right? And then here, there's 3 x's, here there's 2 x's, and here there's 1 x. So here I have 2 2's, 2 2's, and 2 2's, and an x, and an x, and an x. 2 times 2 is 4, and an x. So my GCF is 4x, which means that is what goes in the front of my factored form. Now I'm asking myself, 4x times what is 8x to the third? And I can cheat here, right, because I've already done the work. So I can see this is 4x, right? And so what I need to multiply by to get from 4 to 8 is 2. And I have 1x, I need 3 x's, so that's x squared. And notice 2x squared is exactly what's left over here. Here I can see there's a leftover 3x. This is minus 3x. I could have also said to myself, okay, 4 times what is 12? Oh, 4 times 3 is 12, and it's negative, so it's negative. Here's 1x, I need 2 x's. 4x times what is 20x? So 4 times 5 is 20. And since I already have an x here, I don't need any more x's to make it 20x, and that is my factored form. Let's take a look here. We know that when we see a negative out front, we're going to make the GCF negative. And the reason is because we always want this first term, this one here, to be positive. So I'm going to make the GCF negative, and then what's the GCF of 20 and 30? And hopefully it just jumps out to you that that GCF is 10. If you factored it out, you'd see that they each have a factor of 5 and 2. Then we also have 4 n's here and only 1 n here. So it's just the 1 n that they share. So my GCF is negative 10n. And when I pull that out, negative 10 times positive 2 is negative 20. And I have 1 n being multiplied here, and I want 4 n's. So I need to multiply 3 additional n's. And then here, so this is negative times negative is positive. 10 times 3 is 30. And then I already have an n here. I'm multiplying an n, and I'm only wanting to multiply by 1 n. So multiply 1 n, and I already am. So I don't need any more n's, and this is my answer.